Hello everyone. Yeah, my first OPC day, so please be gentle with questioning. Right, so the first OPC day together with actually with our exclusive partner for the region, that being Klingman, covering Baltics, Finland, and a bit of Russia. And we're planning today to give you visibility a little bit over what we have developed in the past months. So we put a lot of effort and time into a new product or a new release, being a new release for our software development kit for the OPC UA. This obviously happened now that we are part of the Honeywell group for a while. We got a better understanding on what the R&D process is or looks like within these big automation vendors. It's also possible because, honestly speaking, we got quite a budget for that from the Honeywell side. Also some external resources. So having a good understanding on what OPC technology is, with a lot of experience in markets like oil and gas, power, discrete manufacturing, food and beverage, and so on. We targeted a new market for us, that being the embedded world, so the embedded manufacturing together for this new release, for this new SDK. But just a few words about Matrikon OPC as a vendor here. You would see that we are working closely with the OPC Foundation, different part of the different working groups. We are also an education partner for the OPC Foundation. Few things we are just a few of them we are really proud of, like the first DCOM solution on the market, or the first OPC UA server certified by the OPC Foundation. Numerous times the Control Organization Reader's Choice Award. And with a portfolio nowadays covering from anything from embedded deployment of our SDK up to cloud solutions. We are the largest OPC vendor in the world. Why OPC UA? Because of three key points that will allow any product vendor or any software vendor to move into this IIoT world. And the first one being, of course, the open data connectivity. It's a huge step in not relying on any third-party services like COM or DCOM or any third-party technology. It's a huge step in moving towards handheld devices, because they are flooding the operator's room, and people is more and more engaged with this sort of devices because of the preservation of the data context, part of the OPC UA model. So in here we are working with complex data modeling. We are leveraging semantics. So complete data exposure over complex infrastructure like HMI, PLCs, or remote IOs, or even 3D printers. Another key point here for the OPC UA, as we see it, would be of course, the security, which is built from ground up, recognized by most famous and trustable organizations in the world, and based on the latest security standards like the certificates. The result of that would be OPC client-server architecture from ground up, exposure to data and converting that data into information from device or sensor level up to business IT level. So you would see here how OPC UA is being deployed in the process control network, in devices and controllers, running real-time operating systems, or actually no operating system, bare metal devices, in middleware, in DMZ, or demilitarized zones, or even in the up to the business IT level, connecting or helping ERPs like SAP to connect and get the data, pull the data out of the process. Now we have just released version 3 of our SDK, software development kit, which aims to be a very scalable package that you could use for embedded devices up to PC-based applications. We actually have had an application where our SDK was deployed in a device with 50 kilobytes of RAM out of a total of 64. So we're looking at a very small footprint, a nano profile implemented, up to multi-threaded PC-based applications, clients or servers. We use our own ANSI stack, and we're trying to stay out of the heap allocation memory, so we have our own patented memory management algorithm in order to keep the fragmentation to a minimum. Now, of course, our being that small footprinted and that highly performant, it's being based on an ANSI stack. As I mentioned, doesn't use the system heap memory allocation, and it works in both single-threaded or multi-threaded implementations under different real-time operating systems or even bare metal devices. The main highlight of this release, is the scalability and the multi-threaded application for this SDK. We used to have all sorts of implementations up to now. So we have different agreements in place with some large automation vendors. But with this new release, we already got some new ones, and you will see a couple, actually 3 of them, at the end of the presentation. So I will show you some case studies where we implemented successfully this SDK. We do support the nano and the embedded profile. We do support the security and the methods. And as you can see it here, we are actually covering up to 50 sessions and 5 subscriptions for the PC-based applications. Easy to implement. Actually, it took for the Schneider developers only a few hours, like 3 hours, together with our developers, to deploy that in one of their PLCs. that happened a couple of months ago. As easy as you would add a thread in your own device in there. It does support the 30-bit microprocessors, and yeah, it requires a C++ compiler. We've run a number of tests here, and you would see that we managed to pull 1,000 tags at 100 milliseconds with a CPU usage of below of around 30% for a Cortex-A8 microprocessor, and for the nano profile we were reading continuously about 100 tags from an ARM Cortex M4 microprocessor with a CPU usage of less than 15%. Actually, we loaded a standard Office laptop with 1 million tags using this SDK, which ran perfectly. So scalability is the keyword. Part of the scalability or the approach towards the embedded market, we do have a number of testing boards. One of them is over there at our table in the demo section. So all of them are being used to build up some confidence in the OPC UA technology and furthermore into this SDK. But the main value for the end user, for the end customer, will be having a very deep visibility over what's happening on the shop floor, because there are so many devices, so many sensors that that generate data, and we need to get that data up to the control level, or furthermore to the business level. And this is the most cost-effective way to do it. Then, of course, the ease in integration for the end user is something that would pay off at the end of the day, because it's plug and work, as someone mentioned before. We do look at security, of course, so encryption, standard security. It's built in the SDK that we are promoting, and the overall cost of ownership, it's something that most of the end customer are looking at when they invest into the new technologies. So not needing a computer running the OPC servers, classic OPC servers, IT staff to maintain that computer, those computers, and less training, everything will wrap together in lower cost of ownership. But again, for the vendors who would use our SDK to deploy it in their devices, it all starts with the value proposition that they would they would put on the market, because having OPC UA compatible enabled devices will not only allow them to approach new markets, but it will have an important meaning when they would promote their devices towards their end customers and among the competition that they may have. Margins, obviously, sometimes it's all about reduced time to market, and having a package, a software package that would bring so much value to a device that it only costs like sometimes less than $5 US dollars. It's a key point here. Lower cost even for their inventory. I mean, if they would have to propose a solution to an end customer, sometimes the vendor would require to use third-party assets like third-party OPC servers, like gateways and so on. And this, having the OPC UA server embedded into the device, in the end will result in reduced inventory. The new markets that they can approach, this is something I've seen with my own eyes. Sometimes they would be able to sell, to create new products, like selling services or software as a solution rather than a hardware device. I've seen it with Atlas Copco. Some time ago in South Africa, they would be able to, having everything wrapped up into this OPC technology and being able to monitor this geographically dispersed assets, they have been able to actually not rent their compressors or sell the compressors as it is, but sell a service, sell a certain amount of compressed air or a certain amount of or a certain flow, right? Then let's not forget the future proofing, which is a wow factor. This is a de facto open connectivity standard, and it's progressing really fast into most of the markets. Now, I mentioned a few case studies. One of them, which actually happened with this release, is something that has to do with Oracle. Oracle reached to us because they wanted to get some traction in the process industry. So they wanted to get visibility in process industry for their cloud solutions. They would need a sort of connector to pull the data out of the process, sometimes not directly from the process, but from VCSs or historians, but sometimes also from the shop floor, like PLCs and sensors, and move that data up to their cloud and run some analytics. What we provided them was basically a solution relying on our industrial data logger. So a device containing all sorts of drivers, I call them drivers, actually OPC servers, here connecting to the process. Everything wrapped up in OPC UA technology, and then together with our SDK, using our SDK, they managed to develop their cloud connector. So that small device on the bottom right, you would see in there, the data logger acted like a local store and forward solution. Had a small buffer inside, capturing the data and keeping that for short-term reporting, and sometimes in case of communication line disruption, that would be backed up in there. The UA client that they developed with our SDK is now part of their IoT cloud client libraries as a standard. Actually, they presented at the Oracle Open World this year, like last month in US, and they even have a mobile app for notifications. Another case study, an interesting one, which is from end of last year. It's about Areva. Areva in Germany, they have this C-plug relay, which is monitoring basically the valves in the nuclear power plants. It's like a power analyzer. They are monitoring the current and the voltage. So this way they could tell that the valve is completely closed, completely shut down or opened, and so on. And through this relay, they are able to send some comments to the valve there. So they do have a connectivity solution. They do have a software application called Adam, as you see it in their own proprietary protocol, which is logging some information from this relay. But what they needed was actually an open world connector, and that would be an OPC embedded UA server. So the challenge here was to avoid any hardware changes because of the nuclear NERC certifications. So we need to use the hardware that they had. It would be an ARM M3 microprocessor with less than 100 kilobytes of RAM. So we implemented our OPC UA SDK with our own stack in there, enabling Areva devices to connect through OPC UA. The good thing is that the old proprietary connectivity or protocol still works, so they can use that at all the time. This is actually the funny thing with the technology, you only notice it when it doesn't work, isn't it? So they could use that at the same time while using the OPC, the embedded OPC UA server inside. Another interesting case study would be, well, this is interesting as well because we used to bundle our UA server with some of the Infineon boards here in Austria. So Infineon markets that as boards especially designed for PLCs, manufacturers, controllers, gateways, and so on. They do have our OPC UA server on board, and they are even used by some of the major automation vendors for their power meters. Of course, the smallest footprint in the industry was a key point here, as well as no heap design for our SDK. And finally, another one with Emerson. I think I've seen this CSI case study a little, just before from Stefan, wasn't it Stefan who presented it? This is actually a condition monitor, more the condition monitor actually from Emerson. They are using that for monitoring the rotating machines within a factory. Looks like about 10% of the rotating machines are causing 90% of the process stops in factories. So they have more than a condition monitoring panel because it runs some analytics and some predictive analytics. What Emerson would need to do with part of their market strategy, part of the marketing strategy was to be able to connect this system with upper level systems like DCS's, MIS systems, and so on, even historians. For that, they would require an OPC UA server, which got embedded into their devices successfully. So we do have another happy customer. That should be pretty much it about this new release that we have. We are looking to have a new one in this quarter, so by the end of the year, supporting historical access. That would be the missing feature so far. And hopefully somewhere next year we'll add some more features from the OPC UA specifications. Thank you.